Okay, question number 4, we have an inequality with a modulus sign. So with modulus inequalities, what I would normally do is solve it like an equation and then sketch a graph to find what region we need. So the first thing is we do need to rearrange this so that we just have the modulus function on one side and everything else on the other side. Given that we have a negative term here, a good thing to do would normally be to take that to the right hand side just so that you don't have to divide by a negative, right? But in this case, I am going to keep it on this side just as a reminder that when you divide by a negative, you do have to switch the signs around, right? So in this case, the first thing I'm going to do is subtract 12. So this is going to be minus 2 times 2x minus 3 is greater than or equal to minus 5. So subtracting 12. I can then divide this by minus 2, but at the point where we divide by minus 2, we need to remember to switch that sign. It's very easy to forget that, which is why putting all of this bit to the right hand side first may not be a bad idea, right? So as long as you remember to switch the sign, so this is fine. Dividing by minus 2 makes that 5 over 2. So now we have 2x minus 3. The modulus of 2x minus 3 is less than or equal to 5 over 2. Now, what I then want to do is to pretend that this is an equation just to find where these two lines would intersect, right? So let's just imagine we are solving 2x minus 3 is the modulus of 2x minus 3 is equal to 5 over 2. And the way I would normally do that is to split this into two parts and first solve 2x minus 3 is equal to plus 5 over 2. And then as a second part, solve 2x minus 3 is equal to minus 5 over 2, right? So if you solve this, so this should be fairly straightforward to solve. It's just a linear equation. If you solve this first bit, we get 2x is equal to 5 over 2 plus 3 would give you 11 over 2. Dividing by 2, that gives you 11 over 4. So that's going to be one of the point x coordinates of where these two lines would intersect. Then solving the other equation, you would get 2x is equal to, so adding 3 again, we get 2x is equal to minus 5 over 2, add 3, that would give you plus half. Dividing by 2, that gives you x is equal to 1 over 4. Now, in terms of solving the inequality, I would definitely use a graph for this. So let's sketch these two graphs. And the way you'd want to draw a modulus function, so I'm first going to draw this straight line here, 2x minus 3. So 2x minus 3 is a line that has a gradient of 2 and a y-intercept of minus 3. But if you take the modulus of that, everything below the x-axis, so the original line would have been like that, but everything below the x-axis just gets reflected and goes that way. So this point here, the y-intercept would be plus 3 here. Now 5 over 2 is less than 3. So the line y is equal to 2. So I'll draw that one here. So the line y equals 5 over 2 would be a line that's something like that. So this is y is equal to 5 over 2. And this is the modulus of y is equal to modulus 2x minus 3. So the 2 points where they intersect, so these two coordinates, these two x coordinates are the two x coordinates that we've got. So one of them is 1 over 4, the other one is 11 over 4. And what we are looking for here, if we say the modulus of 2x minus 3 should be less than or equal to 5 over 2, what we're asking is for what values of x is the red graph below the blue one here. So the range of values that we want here is going to be, so the part of the graph where the red graph is below the blue one is all of these values here. So that is when x is in between 1 over 4 and 11 over 4. So the final solution to this should be that x must be greater than or equal to 1 over 4, but less than or equal to 11 over 4. Right? The original inequality sign was a less than or equal to sign, or greater than or equal to sign. So in this case, both of these values are included.